soul, cause hip hop is old. She don't want no rock and roll. She want platinum or ice and gold. She want a whole lot of sun to fold. If you were obstacle.
Here we have a circuit with a bunch of capacitors, and we are asked to evaluate the total capacitance of the circuit, which means finding the equivalent capacitor that has the same capacitance as all of three combined in this orientation. First of all, we want to reduce these two guys into one single one. So the simple trick for finding the C equivalent of these two would be to have, because they're in series, it's their product divided by their sum. And now when our equivalent capacitor situation looks like this now, so we have C1 here, and here we just calculate the C equivalent of 2 and 3, and now these two are in parallel, so that's easy. Their combined capacitance is just the sum of the two. So the C total would be C1 plus the C equivalent of 2 and 3, which is C1 plus C2 C3 divided by C2 plus C3. In part B, we are supposed to determine the charge stored on each capacitor. So let's start by saying that we have Q1 here, positive Q1 on this plate, and this plate then has negative Q1. In the same manner, we have some positive charge Q2 here, and it's positive, and the negative Q2 on the other plate. And this happens because when charge Q2 is brought to this plate, it will attract same amount of negative charge here and repel the equivalent amount of positive charge away, and in fact to this plate. So here we have also plus Q2, and on this other side minus Q2. The other thing that we know is that when we have this potential difference between these 2 points, the same potential difference is here, and this branch is no different, also here. Amount of charge on a capacitor can be solved from this relationship Q equals C times V. So we can pretty easily solve for the charge on the capacitor 1. So Q1 is C1 times V, which is C1 in 22 microfarads times the voltage, which is 34 in this case. And this will give us 7.48 times 10 to the minus 4 coulombs. What about the other two? We know that the total potential difference over C2 and C3 must equal V. So we can say V plus V3 must equal V. What is V2? From solving this relationship, V can always be expressed as Q over C. So we get V2 is Q2 over C2, and V3 is Q3 over C3, whole thing equals V. But as we know, the charge on the third capacitor is same as on the second, so we can say already that they have the same charge, Q2. Okay, what about C3? C3, or let's put it this way, the C2 is twice the capacitance of C3. So we can say, instead of having C2 here, we can replace by saying it's 2 times C3. And now we combine these two terms, so it's Q2 plus 2Q2. So I multiplied numerator and denominator by 2 here. 2 times C3 equals V, which gives 3 times Q2 over 2C3 equals V. And solving for Q2, 2/3 of V times C3, and 2/3 times volt is 34 volts. And what is C3? 2 times C3 is 11 microfarads, so 1 C3 is 11 times 11 times 10 to the minus 6 farads. And this gives us 2.49 times 10 to the minus 4 coulombs. So let's gather the results. So Q1 was 7.48 times 10 to the minus 4 coulombs, and Q2 2.49, but we know that Q2 is same as Q3, so they're both 2.49 times 10 to the minus 4 coulombs.